Get all the parentheses, right? I mean, oh. Okay. Let's go ahead and just take a look at this step by step. K is greater than 0 and x equals to 0. Well, I don't think we can actually do any simplifications at this point. What about the other side? The big, huge mess here. But they're all conjunctions, right? The other side, they're all conjunctions. K is greater than 0, and x is greater than 0, and x is less than or equal to k, and x is less than k. Can we do at least one simplification here? We can get rid of one of these two. Okay, these two are somewhat related. Which one is a superset? We get rid of the superset in this case. Yep, we get rid of this one. We keep the more restricted one. Okay? So the way we do this is we say x is greater than 0. Oops, excuse me. K is greater than 0. X is greater than 0. And x is less than k. Just like that. Can we do more simplifications here? If you look at and as multiplication, or as an addition, can you use the distributive law and do a little bit of simplifications here? Can we pull k is greater than 0 out of both of these and just say it's going to be k is greater than 0 and da 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 da? It's the distributive law. Okay, you guys do remember the distributive law in arithmetics, right? In arithmetics, you can say a plus b times c is the same as ab plus ac. If you look at, sorry? Oh, BC, sorry. But if you look at this, and say multiplication is like conjunction, and then you say addition is like disjunction, then we can also apply the same trick to Boolean expressions. Okay? So in this case, we can simplify that thing to k is greater than 0 and x equals to 0, or x is greater than 0 and x is less than k. And that. Okay. Now, are there any ways to simplify that? Looks kind of hairy, but you know what? We can actually simplify that too.
Do the same thing to x.
Sorry, go ahead.
X is greater than or equal to 0. Can you do that?
Well, we can. One thing we can do is to expand it. Remember what I said, about. As it turns out, in Boolean expression, the distributive law applies in both ways. Okay, in arithmetic, it only works in this form. When you have multiplication on the inside and addition on the outside, it does not work. But in Boolean expression, it also works the other way around. Okay. So this part is not something that I would expect you guys to do, but I do want to expose you to it because it is very useful in programming. Why is it useful in programming? I mean, I don't want to teach you guys anything that would not be useful, okay? But why do you think knowing these rules for simplifications and manipulations and stuff like that would be useful for programming?
Helps you define your conditional statements.
It helps you understand your conditional statement, okay? If you start off with a conditional statement that is a condition that is this long and really cumbersome and difficult to understand, if you can apply these tricks and shrink it down to something that is about this long, it makes your code easier to understand. Now think about that in the context of a multi-branch conditional statement. If you have a multi-branch conditional statement and each condition is like this long, how can you be sure that you don't have any dead branches? It'll be pretty hard, okay? Because you look at all the conditions that each one is this big. How do you know that this condition will cover everything that this condition will say? It's not easy. On the other hand, if you can do simplifications and reduce all the conditions into their simplest form, then it becomes much more obvious. You can pinpoint and say, oh, this condition is this, and this condition is just a subset of that, so this action is going to be a dead branch. So that's why being able to do the Boolean algebra stuff like what I'm doing right now is beneficial. Is it required? No. Okay? But if you want to check your program and debug your program effectively, it is helpful. Okay? So I just want to point out, what is necessary and what is desirable, because they're not necessarily the same thing. Okay, so in this case, we will, just do the trick here. We'll say becomes x equals to 0, or x is greater than 0, and x equals to 0, and x is less than k. I forgot something. Like that. I'm just trying to match all the parentheses here. I think missing one, last one, like that. Now, can we do some more simplifications? Is there another way to say something like this? X is greater than 0, or x is greater than 0? How about we just say x is greater than or equal to 0? Same thing, right? So this one simplifies to x is greater than or equal to 0. What about the other side? What is another way to say that x equals to 0 or x is less than k? Now k is guaranteed to be greater than 0 to begin with. Now that's important, because if I don't have that assumption, I cannot do this simplification. Is one of these a subset of the other one, knowing that k is positive? Yeah.
It looks like the one side is the same as x is greater than or equal to 0 is true on both sides of the and.
No, we're just focusing on this part here. We're just focusing on the disjunction. Can we simplify this part, knowing that k is positive? Can we just say that, can we just get rid of this part here?
Yeah.
Yeah. Now we can get rid of this part here because this is a disjunction. In the disjunction, and the two sides, one is a superset of the other one, you keep the superset. Because with a disjunction, you're trying to include as much as you can. So you keep the one that includes more numbers, and you get rid of the more restrictive one. So that means, we can simplify this, and it simply becomes x is less than k, just like that. And, in a case like this, with, and inside the parentheses and the and outside the parentheses, we can just get rid of the parentheses because, they're all just quote-unquote multiplications. So there's no need to really specify which one has to happen first. Have we seen this condition before? Where have we seen it before? That's our precondition to start with. Right? This is pre-1. Before line 1, I'm guaranteed this condition. This is post-4. After this pseudocode, we arrive to the same condition. Okay? Yep?
Why doesn't it change if x equals x plus 1? Why doesn't it change? Why is it still the same?
Why is it still the same? Because we don't do that. Okay, are you referring to
Line 1.
line 1?
Yeah.
Well, because as an end result of line 1, it might trigger me to go to line 3. And as a result of line 3, it will bring me back to the same condition that I started off with before line 1. Okay? But this is all working out. Yep.
Because the lowest number x will be 0, and because k must be greater than x, the next step should be we could eliminate k is greater than 0 because it's already implied.
Yep. Now, if you look at this code here, you will say that is just some useless code, right? I mean, we start off with a condition, we go through this code here, and we end up with exactly the same condition. It is as if, from the perspective of pre and post condition, it is as if this code did not happen. But that is actually not true. If you look at the exact value of x, there's no guarantee that the value that I started off with here is going to be the same value as x will have here all the way down here. Okay? Because the condition does not say anything about the specific value of x. It simply says that x will still be greater than or equal to 0, and x will still be less than k, but it doesn't say that if x was 1, it will still be 1. If x was 2, it will still be 2. It simply says that x will maintain these relationships, these comparisons. So it is not saying that this code does not really do any changes to x. It simply says that the precondition that has to be true turns out to be the same as the post condition that also has to be true. So you have to remember that, okay? Because it does not say that x nothing happened to x. It simply says the same conditions have to be true. Yep.
So if we do all of this and post 4 doesn't equal pre-1, then we've done something wrong?
That is correct. Now, you may or may not have done something wrong because the twist to this one is the assumption that x is an integer. Okay? If you did not make an assumption that x is an integer, then you would arrive to a different conclusion. Okay, so you might have, if your answer is not exactly the same, it is most likely because you did not say you did not make that assumption. Okay, I think that's the most tricky part of this one. But the fact that you guys have tried it is good. Okay, if anyone has given it some time to think about it, to try it out, it is already a good sign. It is actually a little bit tricky because I didn't mention here that x is an integer. So if you do not arrive to the same conclusion, it's fine because if x is not an integer, then it will be slightly different. Okay. Are there any questions about this one? No questions? Any questions about loop invariance? the loop invariant thing that we talked about last time, the really nasty stuff. Yeah, you remember that? Okay, well, that's pretty much the end of the pre and post condition stuff. So let me save this first, okay, before I forget. Because I can always save it and keep editing a little bit later on. Yep.
I was wondering, I noticed that on Moodle, this was posted yesterday in a PHP file. Can you save it? Open on Moodle book. Is there any way to open it up in a text editor so you can print it out?
I'm not sure which one what are you referring to?
You had this posted on a Moodle site last night. This sample homework assignment is not
Yes.
graded.
And
when I opened it up, it opens up in Moodle. But I was wondering, is there any way I could open it up in a text, save it as a text document, and open it up in Word or something so I can print it out?
Yeah, you can just copy and paste it.
Oh, okay.
See, I just copy, and go to Office, go to Writer, which is the word processing component, and go through this, paste it. So it's definitely doable. Yep.
Thank you.
It's just HTML. You can print it out directly from within Moodle too if you want to. Yeah, but
I didn't see the print. You can just click it. You can just right-click it and it'll print it out, or I didn't see the print tab on top of the.
You can, depending on your browser, with Firefox, you can just select a portion, go to File, sometime, anytime. Okay, so you go to File, you go to Print, and then you go to Page